Hello, everybody. So what we're going to do today is we're going to go into inverse functions. Now, we just finished up composition of functions and operation of functions. So going into inverse hopefully is not going to be too bad. What we're going to be covering is we're going to learn how to verify if two functions are actually an inverse. And then we're actually going to find inverses of functions. And then we're going to use what's called the horizontal line test, which is similar to the vertical line test to determine if a function has an inverse or not. And then we're going to use the graph of a function to actually graph its inverse on the same axes. So that's what we're doing. So let's go ahead and get started. So an inverse. So when you first saw inverse functions back in Algebra 1, when you did inverse functions, it was primarily with your xy coordinates. And the rule is if you're trying to graph an inverse, you basically switch your x and y, and that would become its inverse. Well, the same is kind of true here, except now we're going to look at in terms of equations. And what we're talking about in terms of equations is an f of x, and a g of x. And the first thing that you're going to wind up having to do is verify if they're inverses or not. And how you do that is you're going to take your first equations, your f of x equation, and you're going to compose it with g of x. And if you get the answer x back as your final answer, then fx and g of x are inverses of each other. And the vice versa. So if you take g of x and compose it with f of x, you should also get just x back as an answer as well. So when you do that, that's one of the things that you're going to be looking for when you're actually trying to verify. When we talk about inverses, this is the notation f of -1 or g of -1 or whatever, but anything basically raised to -1 power. Basically, it's not really a power, so don't think of it as a power, okay? This is a representation stating that that this is an inverse that we're looking at. So just be aware as you're going through this that that -1 is not a power. What this piece here is saying is that if I give you your two functions and you compose them, you should get just the answer x back. And as long as you get that answer x back, they're inverses of each other. So basically you can say if I have f of x, then its inverse would be f of -1 x. Well, if you compose f of g of x and you wind up getting an x, then you can say that g of x is an inverse of f of x. So that's what it's talking about when it's asking you to verify. So let's actually talk about it or look at it, and let's go from there. So I need to show that these two are actual inverses of each other. So one of the things I want to do is I want to say, okay, if that's the case, I'm just going to go ahead and start off composing f with g of x. So that means I'm going to come over here because remember f is my focus and g is my substitution. So I'm going to say 4 times x plus 7 divided by 4 minus 7. My 4's will cancel. That leaves me with x plus 7 minus 7. So my 7's are going to cancel. And that leaves me with just an x. So I can say that g of x is the same thing as f inverse of x. And if I do it the other way around, and I look at let's try again. If I look at g of f of x, and I compose these two together, so I get, instead of x, I get 4x minus 7 plus 7 all over 4, which means that when I combine these together, I get 4x over 4. My 4's will cancel each other, leave me with an x. So then I can turn around and say that f of x is the same thing as g inverse of x. So by doing this, I have shown that f and g of x are both inverses of each other. Okay. So when it's asking you to verify, this is what you are wanting to get. You want to get that single solitary x by itself. If you wind up with x plus 2, if you wind up with 5x, if you wind up with anything else and there's no way to get rid of it, then you do not have an inverse. Okay? It has to be a plain old everyday lonely little x. All right? All right. So let's actually find an inverse now. So I'm going to give you some steps and then we're actually going to go through the process of actually finding the inverse of a function. So the easiest way to do it is we're going to go ahead and we're going to take our f of x. Instead of having f of x equals something, or g of x, or h of x, or whatever it is that they give you of x, you're going to take that and you're going to say, all right, well, I don't want f of x no more. I want to make that a y. Because it's a lot easier, because in step 2, everywhere I see an x, that's going to turn to a y, and everywhere I see a y, that's going to turn into an x. So you're interchanging x and y. And then we're going to wind up solving for y. And then once we solve for y, when we get to the very end and we can't change it anymore, then we wind up saying, oops, I went too far. We wind up saying that if I've gone through the whole process and I have y equals something, we wind up saying that that's the inverse. And if you have to prove it, then you do step 4, where it says then you're going to take that inverse answer and plug it back into the original equation, back into f of x, back into g of x, back into whatever, and then you should wind up with your lonely little x by itself. So let's take a look at this. I want to find the inverse of f of x is equal to 2x plus 7. And so I'm going to come over here, and step 1 says instead of writing f of x, I'm going to write y. Now what I'm going to do is everywhere I see an x, I'm going to replace it with a y, and everywhere I see a y, I'm going to replace it with an x. So I'm going to interchange my x's and y's. Like that. Step 3 says, okay, once you do that, I need you to solve for y. So I'm going to solve this for y. So I'm going to move my 7 over. And then I'm going to divide the whole thing by that coefficient. And since there's nothing else to do with that, I'm going to represent that as y inverse. So when I say find the inverse, I'm going to say f of negative 1 x is equal to x minus 7 over 2. Okay? So just when you go through this process, make sure that you're watching out for your x's and y's. Make sure that they're going in the right positions and everything else. And so that way you're not losing out on how to do any of this stuff or whatever. Okay? All right, let's try it again. So this time we have a power here. So we're going to follow the same steps. So I'm going to go ahead and turn this into a y. And that's going to be x cubed plus 4. And then I'm going to switch them. X is equal to y cubed plus 4. And then I'm going to solve for y. So I'm saying, okay, well, this becomes x minus 4 is equal to y cubed. In order for me to get rid of the cube, I got to take the cube root of both sides. So I'm going to cube root here, and I'm going to cube root here. So that way I can get rid of that cubed over here. And then I'm left with y is equal to the cubed root of x minus 4. And since I can't do anything else, that would be my inverse. All right. So hopefully when you go through this process and you're trying to, find the inverse of this, it should be hopefully relatively simple for this. Just take your time and make sure that, if you have to undo your roots, then you're squaring, you're cubing or whatever. Or if you already have a square and cubed, you have to do your roots for it. Making sure you're trying to focus on getting that y by itself. Don't forget to divide. Watch your signs. The biggest one is watching the signs. A lot of people forget to watch their signs when they go through this whole entire thing. So, all right. So let me give you one more to try. So I'm going to say, I want you to pause the video after I write this down, and I want you to find the inverse of 5 minus 3x over 2. So find that inverse. So go through the whole entire process and find the inverse and see how that goes, and pause the video now. All right, welcome back. So let's see how you did. So we're going to change. That gives you 5 minus 3x all over 2. So x is equal to 5 minus 3y all over 2. So this gives me 2x is equal to 5 minus 3y. So 2x minus 5 is equal to a negative 3y. So y is equal to a negative 2x plus 5 all over 3. And there's nothing else I can do, so that would be your inverse. Okay. Hopefully there's no questions on that, because I'm about to ask you if there were any questions, because, as a teacher, that's what I like to do. But hopefully that wasn't too bad, and that, it's very nice, very easy, very simplistic for you to be able to do. So just again, watch your signs when you do this. Make sure you're following your algebra rules, stay balanced, everything else. Okay? All right. Oh, I guess I did that one. Yep, I actually did that one. So we're not going to worry about that one. Let's talk about horizontal line test. All right, so this is an extremely easy thing. So remember how we had, when we were checking for functions, we had what was called the vertical line test, where you draw a whole bunch of vertical lines up and down to see if it crossed the graph one time or multiple times. The horizontal line test is the exact same thing. But what you're going to do, instead of drawing vertical lines, you're going to draw horizontal lines. And as long as the graph is only intersected by the horizontal line once, then that graph actually has an inverse. But if that graph is crossed more than once, then that graph, even though you can find it algebraically, graphically it does not have an actual inverse. So we need to pay attention to that and be aware to that. When we talk about the existence of an inverse, a function has an inverse if and only if it's 1-to-1. And being 1-to-1 basically says for a and b in its domain, f of a is equal to f and b implies that a equals b. So basically you can't have the same y values and two different x values. That's what it's saying. So your parabolas, if you have a parabola, for instance, that would fail a horizontal line test because you have two y values. I lied to you. You have two x values for one y value. Even though it is a function, it's not a 1-to-1 function, so therefore it actually truly does not have an inverse. So it's basically every y has to have its own private, personal x value, and each x value has to have its own private personal y value. So x values can no longer share the same y value like you can in a quadratic formula. So one of the ways that we test that is through the horizontal line test. So you're going to be given a graph, and they're going to want to know, are these graphs, do they have inverses or not? And literally all you do is come over here and draw horizontal lines across the graph. If those horizontal lines cross the graph more than once, then you do not have an inverse for that specific graph. So notice that A does not have an inverse. If I come over here to B and do the same thing, it does not have an inverse. Now, you're going to argue with me about this one right here. Well, don't they touch all the way down? The answer is no, because as x gets smaller and smaller and smaller, your y is getting smaller and smaller and smaller, and it's running an asymptote to the x-axis. So even though the graph looks like it's crossing and touching the x-axis, that actually isn't ever touching the x-axis. So that's why B is an inverse and A is not, because in B, the horizontal line test actually passes here. Okay, so extremely easy. When in doubt, graph it out, throw it in your graphing calculator, draw some horizontal lines to see if it actually has an inverse. So since we're talking about graphing, let's take a look at it. So when we are graphing just lost my train of thought. When you're graphing an inverse, if I give you a point, in order for it to be an inverse, because that's what I want it to do, I want it to be an inverse, all you do is switch your x and y's around, and then you plot that point once you switch your x and y's around, okay? So what that means is this. If I have this graph here and I want to find the inverse of this graph, I'm going to come over here, and so in red are the original points. So my original points, we've got in order. Make sure it is in order from left to right. Please don't do this in a different order. If you do it in a different order and then try to connect those dots, it's not going to work out correctly. And then we've got 4, 1. So what we're going to do is we're going to inverse these points here. So we have -2, -3. We have 2, -2. And we have 1, 4. And then we're going to take our new founded points that we have done over here, and we're going to come over here on our handy dandy little bitty graph, and we are going to plot our new points. So I'm going to go over to -2, -3 and put a dot. And I'm going to go to 2, -2 and put a dot. And I'm going to go to 1, 4 and put a dot. Okay. So if I did that correctly, make sure I did everything correctly. And then we're going to play connect the dots in order, the way you put them down. This, and then that. And then there you go. So when you're actually looking at it, this is what you're looking at. All right. So now, here's the question. How do you know? How do you verify? You don't have an equation here. You just have a partial graph. So how do I know what I did actually worked? You draw the y equals x line. And what you are looking for is this. Let me get a nice color here. Let's go green. If I'm going from this point to this line, so I want to know, I'm going to go from here to here. If this is a true inverse, I should be able to pick this line up and go from this point 0, 0 here, and it should touch that over here. Okay? And so if you notice when I do that, it does. That is a true inverse. Because an inverse, this point is going to be the same distance from that y equals x line as this point here. The same thing is true over here. If I come over here and go from here to here, and then again, if I pick this up and I measure it from, from this way to that way, you will notice again, I didn't change the width or the length or anything else, and it still went the full distance. And so that's what you're looking for when you're doing that. So if you're ever in doubt, and your grids or your graphs are going to have little bitty grid boxes, so you can actually count the boxes, how far away you are actually from the actual line here. And then you just want to make sure that if this is, 3 away, then this should also be 3 away. If this is 4 away, this also should be 4 away. If this is 1 away, this also should be 1 away. Okay. So when you're going through that, just keep that in mind, so that way you know that you actually have done it correctly. All right. So that is inverse functions. That is 2.7. So what you're going to do now is make sure you go into your Blackboard and look at your homework for there. And if you have any questions, make sure you're hitting that Ask Your Instructor question button. Remember, that will go to my email here in Paris, but you are going to have to check your Dragon email to make sure that when I respond back to you, you actually get it. Okay? All right, well, if there's no other further questions, because you can't ask me anyway, because I'm actually creating a video while all y'all are at home on this beautiful half day. So I'm going to go and I'm going to make another video, and I will talk to you soon. TTFN, ta-ta for now.